this video, we're going to differentiate the inverse tangent of the square root of 2 cosine x minus 1. As we can see, we have the 2 cosine x minus 1 instead of the square root instead of the inverse tangent, right? So we have to use the chain rule twice. So let's get to work. First of all, when we differentiate inverse tangent, we will get 1 over 1 plus whatever we have right here. Putting the parentheses, you square that, and then the inside stays the same inside of the parentheses. So we write down square root of 2 cosine x minus 1, like that. And then we have to multiply by the derivative of the inside because chain rule says so. So let's see. When we differentiate square root of something, we first get 1 over 2 times the square root. And the inside right here stays the same. So I will write down 2 cosine x minus 1 like this. But are we done? No, because we have to do the chain rule again. The inside of the inside, which is the 2 cosine x minus 1, we have to differentiate that and multiply the result right here, right? So when we differentiate 2 cosine x minus 1, we get negative 2 sine x. And then the derivative of minus 1 is just 0. So this is what we have. And this is the multiplication. That's put on parentheses. So that's pretty much it. And now notice, of course, we see this 2 and that 2 cancel. So we can just cancel this out nicely. And also, this 2, the square and the square root cancel each other, so we can cross them out. And notice, this right here is just now 1 plus 2 cosine x minus 1. Of course, 1 minus 1 is just 0. So we have 2 cosine x right here times the square root of this times negative sign on the top. So that's pretty much the idea, right? So we can put them down together. All the way on the top, we have negative sine x. And on the bottom, we have 2 cosine x. And then we multiply by the square root of 2 cosine x minus 1 like this. Well, we can actually make this better because we notice sine x over cosine x, this right here can be nicely combined into just tangent, and that will be on the numerator. So in the end, we write down negative tangent x over that, which is 2 times the square root of 2 cosine x minus 1, like that. So this right here is the answer. Alright, in this video, we're going to find the third derivative of 1 over e to the x. In fact, we don't have to use the quotient rule because right here, we have e to the x in the denominator. We can actually just write this as e to the negative x. And then we can just use the chain rule to get the first derivative and then do it again and do it again. So from here, let's see. First derivative, I'll just put down y prime. This right here, well, when you differentiate e to something, this part always stays the same first. So you write down e to the negative x. And the chain rule says we are going to multiply by the derivative of this, which is going to be negative 1. And that's it. In another word, the first derivative is negative e to the negative x. And we just do it again. So second derivative, look at this. First you repeat this, negative e to the negative x. And the derivative of the inside, which is another negative 1. And you get positive e to the negative x. And then you do it again. So you have y triple prime. And you get this right here. And the derivative of negative x is just negative 1. So in the end here, you have negative e to the negative x. And of course, we can write this down to the denominator. So we can write this as negative 1 over e to the positive x. Okay, for this question, we are going to find the derivative of square root of t over 1 plus t. Of course, we are going to use the quotient rule. And remember, when you start with a fraction, you are going to end with a fraction. So let's go ahead and draw the fraction bar first. And then before we forget, let's look at the denominator and then put in the parentheses and square that. So square the denominator. And then for the top, let's see. We are going to keep the bottom function and put it here, which is 1 plus t. And then we multiply by the derivative of the top. The derivative of square root of t is 1 over, let me just put on multiplying by 1 over 2 square root of t, right? That's the derivative for this. Well, that's the derivative of that. Yeah. Anyway, and then you minus the top function, which is square root of t, and then times the derivative of the bottom. Derivative of 1 is 0, derivative of t is 1, so you multiply by 1. And that's it. That's the calculus part. Next is the algebra part. The way to fix this is that, well, we have a complex fraction, technically a little fraction instead of a big one, right? So to fix this, it's not that bad at all. Let's multiply the top and bottom, just put it like this, by this denominator, which is just 2 square root of t. And then, of course, let's do the same right here, right? Now, we'll see when we work this out on the top. When you take this times that, this and that cancel. 1 times this is still that, which we have 1 plus t. And then when you do this times that, this is a minus, and square root of t times square root of t is just t. 2 times 1 is, of course, 2, so we have 2t. And then on the bottom, let me just keep it as how it is. So write it as 2 square root of t times 1 plus t squared. And then, of course, on the top, we can just do t minus 2t, and that's just a negative t. So in the end, we have 1, and then combine these two terms, we get minus t, and over the bottom again, square root of 2 square root of t times 1 plus t squared. And then you can be happy because you got this right. All right, in this video, we are going to differentiate this function here. And then the result is actually pretty nice, right? So here we go, f prime of t for the derivative. First of all, we have a sum of this and that. So we are just going to differentiate this, and then we add the derivative of that. That's pretty much all. So when we differentiate square root of 1 minus x squared, the big picture is that differentiating square root, we have 1 over 2 square root, and then the inside stays the same right here. And then you have to use the chain rule. You are going to multiply by the derivative of the inside. Well, the derivative inside is just going to give us negative 2x. So let's put it down right here. So that's it for the first part. Moving to the second one, we are going to add, but here we have to use the product rule. So to do that, we are going to keep the first function, which is x, and we multiply by the derivative of the second, and the derivative of inverse sine function is 1 over square root of 1 minus x squared. And then the product rule says we are going to add the second function, which is inverse sine of x, and then times the derivative of the first, which is going to be just a nice 1. So this is what we have. And now let's fix this a little bit. Notice we have the 2 and 2 cancel. And let me actually just put this up again for you guys. On the top, this right here is x over square root of 1 minus x squared. And then right here, oh, sorry, I have forgot the minus. And then right here, we add x over square root of 1 minus x squared. And what happens? Yes, they are going to be 0. Anyway, in the end here we have the inverse sine of x. And then of course this and that, they pretty much become 0, so you can just cancel them out. So yeah, so in the end, let me just cross this out. This right here, we end up very nicely to get the inverse sine of x, right? So that's it. And in calculus 2, we will see how to go from here backwards to get that. Okay, here we are going to find the second derivative of this function. Y is equal to ln of secant x plus tangent x. So let's get to work. First derivative first. So let me put down y prime for this. The big picture tells me to differentiate ln, we will have to look at this as 1 over, you put it inside down in the denominator, right? That's a big picture. So you put down secant x plus tangent x. And then you have to remember the chain rule. We are going to multiply by the derivative of the inside. This time has 2 terms. Each term is going to give you a derivative, right? So you're going to put down parentheses. Okay, the derivative of secant x is secant x times tangent x. And that's what you have to remember really well, all right? Next, you are going to add the derivative of tangent x, which is secant square x, like that. So this is it. But we are going to get to the second derivative. Don't just differentiate this guy, because in fact, you can simplify this guy very nicely. Well, if you look at this right here, here we have secant, and this is secant square. So in other words, we can factor out a secant x. So let me just put down the result on the top. We have secant x. For the first term, we will have tangent x. And then we add this right here is secant x, right? Because we took out a power over there. So this is the same as that. And this denominator, you see, it's a sum of secant x and tangent x. And right here we have the sum of tangent x and secant x. Of course, the order of additions doesn't matter, so you can cancel this and cancel that. In fact, the answer to the first derivative is just a very nice secant x. And then, to go to the second derivative, it's just that what is the derivative of secant x? And yes, the answer to that is secant x tangent x. And then with that, we are done. Okay, in this video, we are going to find the dy dx for this equation right here. And notice that the y is not isolated. Therefore, let's just go ahead and use the implicit differentiation. Like, why not, right? Especially, this is actually not easy to solve for y by itself. You can try if you would like. But anyway, here we go. Differentiating this part, you first bring the 3 to the front. So we have 3, and the inside stays the same. So we have x plus y inside, and this will be to the second power now. And then the chain rule says we have to multiply by the derivative inside. Notice that here we have two terms. So be sure you multiply with the parentheses. The derivative of x is 1, and then we add y. The derivative for that is dy dx. So let's put that down here. So that's this part. And then moving to the right-hand side, the derivative of x squared is just 2x. And then the derivative of 4y is 4 dy dx. So focus on the dy dx from here. Now, we just have to isolate the dy dx, will be done. So let's see. We have this times that. So be sure you distribute this into the parentheses. The first term you get is this times 1. So we just nicely have 3 times x plus y squared. And then we add this quantity times dy dx. So let's put down 3x plus y squared. And then here we have that dy dx. And then on the right-hand side, of course, we have this 2x plus 4. And this right here also has the dy dx. Now, let's move this to the left-hand side so that we can collect like terms. And this term doesn't have the dy dx, so let's move that to the other side. So here we go. When I move this to the other side, we can factor the dy dx. And as I recommended in the past, let's put the dy dx at the end. So let's see. This part right here is going to be past the 3x plus y squared, stays the same. And then when you move this to the other side, it becomes a minus 4, and the dy dx is right here already. And then on the right-hand side, we have the 2x. Move this to the right-hand side, becomes minus 3x plus y squared. Yes, you know the deal. Divide this on both sides and we'll be done. So in the end, we get dy dx, that's equal to this whole thing, which is 2x minus 3 times x plus y squared divided by all that. So we have this 3x plus y squared minus 4. And I think this is a totally legitimate answer. So I will just leave it right here. Okay, we are going to find the third derivative of tangent x. So let's get to work. We just have to differentiate this 3 times, all right? So first of all, I will just write down the prime notation for the first derivative. Y prime is equal to the derivative of tangent x. Of course, you have to know that is going to be secant square x, right? Now, we are going to differentiate this so we can get the second derivative. And maybe it's also a good idea to look at this as secant x inside and then raise to the second power when you have the power right here. With that being said, when you differentiate this, what we do first is you bring the power to the front and then minus 1 for the power, right? That's the outer function. So we get 2 times, the inside stays the same, so we write down secant x, and then this is to the first power. And then we multiply by the derivative of secant x, which is secant x times tangent x, like that. And before we do the next one, of course, we can combine some of the terms. For example, this and that. This is secant to the first power. This is secant to the first power. So all in all, we can look at this as 2 secant square x, like this, times tangent x, right? So that's what we have. Now, continue the third derivative, y triple prime. Here, notice we do have a multiplication, so we will have to use the product rule, right? But if you have to differentiate this later, you have to use the chain rule. So it's both. Anyway, product rule in action first. We keep this one right here, which is 2 secant square x. Right, that's the first function. And we multiply by the derivative of the second. The derivative of tangent x is secant square x. We know that earlier, right? So I'll actually put this down right here. This is secant square x, okay? And then we are going to add the second function, which is tangent. Okay, this right here is the tangent. Well, we have to now differentiate 2 secant square x. Very similar to this procedure here. Go ahead and put the 2 to the front and then minus 1. So you actually end up with 4 times the input stays the same, which is secant x to the first power. And don't forget to multiply by the derivative of the inside. The derivative of the inside is the secant x. So you multiply by secant x tangent x. This once again is the derivative of the secant x. So that put it down in blue, like that. Okay? So you just have to do this carefully, and then you'll see this is how it works, like that. Well, in the end, let's see. First, we can combine this right here. So 2 times that is just 2 secant to the fourth power x. And we have a 4 right here, so we just say plus 4. Secant, tangent. So both of them to the second power. Let me write down secant first. Secant square x and then tangent square x, like that. And yes, you can factor things out a little bit, but up to you though. Perhaps I'll box this right here for an answer if you would like. It's totally okay. If you would like to keep going, you can factor out 2 and secant square. So if you do that, you get 2 secant square x right here. And then you will end up with secant square x plus 2 tangent square x. And seriously, you can also use some identities to simplify this if you would like. You can write secant square x in terms of tangent or whatever. Okay, we are going to differentiate cosecant square of x to the third power. And in fact, I will write this power down in this form for you guys. This notation means we have cosecant of x to the third power inside. But this 2 means we put this in a big parentheses and then raise that to the second power. Okay? So you can see that we have a lot going on, and we will just do this one by one. Anyway, here we go. Differentiation in action. First, you bring the 2 to the front and then minus 1. So you get 2 times this stays. So you write down cosecant of x to the third power to the first power, right? It stays. And then the chain rule says we are going to multiply by the derivative of the inside. Well, derivative of cosecant is, let's put down multiplication in the parentheses. The derivative of cosecant is negative cosecant of whatever you have inside times cotangent of whatever you have inside. Right? That's the general form for cosecant. Negative cosecant times cotangent of that. Well, don't forget the inside is x to the third power, so you do have to enter that right here. And lastly, yes, we have to do the chain rule again. The derivative of x to the third power, which is very nice, it's just 3x squared, like that. Oh, I just realized like this color is so pretty. You have the sky blue and also have the green. It looks like ocean, you know, it's like at the beach or something. So it's very pretty, very nice, very, very relaxing. All right, so let's see. 2 times negative times 3, of course that's 6. And then we have the x squared right here, so let's put that down as well. X to the second power. And the next, see, this right here is to the first power, and we are multiplying with another cosecant of x to the third power. So first power, of course you get the second power now. So we have cosecant of second power of x to the third power right here. And the last part is this, namely we have the cotangent of x to the third power. And I have the negative right here, so I should have the negative. Yeah, anyway, I know it's not funny if I miss the negative on the test. So don't do that on the test. Okay, we are going to find the derivative of this function here, y is equal to x plus 2 over parentheses 4x minus 1 and then square. Well, we are going to use the quotient rule, so let's get to work. First of all, let's write down y prime, and this is equal to, when we start with a fraction, we are going to end up with a fraction, and before we forget, let's put the denominator right here, and we are going to square that. And don't forget, this right here stays as 4x minus 1 square. So this square is from the original, and then the quotient rule says we have to square the denominator, so that's what we have. Then, on the top, you are going to just write down the bottom function, namely, you have the parentheses 4x minus 1 to the second power, and then you multiply by the derivative of the top function. The derivative of x plus 2 is just 1, so you multiply by 1 right here. And then you are going to minus the top function, and because it has 2 terms, be sure you put it in parentheses. And then you are going to multiply by the derivative of the bottom function. Well, focus on 4x minus 1 squared. To get the derivative of this, you are going to first bring the 2 to the front and then minus 1 to the exponent. So you have 2 times 4x minus 1 to the first power. And then the chain rule says we are going to multiply by the derivative inside, which we have to multiply by a 4, like that. So this right here is the calculus step. Okay? Now the rest is just simplify this guy. Well, to do so, notice that this and that, we have a common factor. We can factor out one of the 4x minus 1. So let's do that on the top. Let me put that all the way in the front. 4x minus 1. And then we are going to end up with, well, for this term, we factored out one of this. So we have just 4x minus 1 left right here. And then this is multiplying, so this is another term. We are going to put on a minus first. This is out already. So we do 2 times 4, which is 8. And we still have this factor. I'll put this down as parentheses x plus 2, like that. Right? And then this is all over this to the fourth power. So 4x minus 1 to the fourth power. Well, as you can see, we can cancel this one with that, so you have the third power in the denominator. On the top here, of course, we can simplify. This right here is negative 8x and minus 16. Well, we can combine terms on the top, and that's pretty much it. So we see 4x minus 8x. Of course, that will give us negative 4x right here and here. And then this is minus 1, minus 16. Altogether, we get minus 17. And the denominator is just this guy, which is 4x minus 1 to the third power. Not too easy, not too hard, just about right. What do you guys think? Okay, we are going to find the third derivative of x times ln x. And because it's a multiplication, so we are going to use the product rule. First of all, y prime, this is going to be, I keep the first function, which is x, and then multiply by the derivative of the second, which is 1 over x. And we add the second function, which is ln x. And we multiply by the derivative of the first, which is just 1, like that. Well, as we can see, this times that is just 1, and this right here is just simply ln x. So that's what we have for the first derivative. And then, let's do it again. The second derivative of, to differentiate this guy, derivative of 1 is 0. Derivative of ln x is 1 over x. That's it. And for the third derivative, we'll do this again. And this is a good derivative to remember. When you have 1 over x to the first power, the derivative of that is negative 1 over x squared, right? So if you remember that, well, you can do some questions pretty quickly. But if not, you can write this as x to the negative 1. Bring the power to the front and then minus 1, and you end up with this, right? Either way. Okay, in this video, we are going to differentiate x to the 1 over x power. Well, the base right here is a function, namely x. The power right here, it's also a function, namely 1 over x. Do not use the power rule, do not use the exponential rule right here. What we're going to do is, we can just take the natural log on both sides, so we can use the natural log property to help us to get rid of this situation. Well, what do I mean? Well, when we have x to 1 over x power, instead of the natural log, we can bring the power to the front. And this right here is just the innocent natural log property, so do not minus 1 whatever. We're just doing algebra. So, you see, we have natural log of y, and that's equal to 1 over x, and you can multiply this by ln of x. So this is just the equation that we'll be looking at and differentiate rather than that one, right? And you might want to put the ln x on the top. In that case, you will have to do the quotient rule. But if you keep it as how it is, you can just do the product rule. All right, so to get to work, let's put on d dx. This is right here. The derivative of ln y, we get 1 over y first. And we multiply by the derivative of y with respect to x, which is dy dx. And then right here, I will just use the product rule. I will keep the first function, 1 over x, times the derivative of the second. The derivative of ln x is 1 over x, and that's it. And we add the second function, which is ln of x, times the derivative of the first function, and the derivative of 1 over x is negative 1 over x squared. And you can also write this as x to a negative 1 power and then do the little power rule. But you will deal with this a lot, so the derivative of 1 over x is this. You can remember that result. Okay, so this is pretty much it, and now we just have to clean things up. Let's multiply both sides by y so that I can get rid of that, and we can find out the dy dx. And we see that the dy dx is going to be the following. Well, y, if you look back, is this, which is x to the 1 over x power. Right? Pretty crazy function, but it's actually pretty famous as well. Anyway, right here, let's see, x times x is x squared. And notice that we also have x squared right here. So in fact, we can combine these two fractions. We can just write them down as x squared in the denominator. From this term, we have 1 times 1, which is 1. And then for this term, we have minus. And then this is natural log of y, so we'll put down natural log of y, natural log of s like that. Anyway, we're done. So this right here is the derivative of x to the 1 over x power. Okay, we are going to find the derivative of e to the negative 2x times sine of x. Well, we just have to use the product rule. But this input, we also require the chain rule, right? So because the input is negative 2x. Anyway, product rule in action first. That's the big picture. Let's write down f prime of x. This right here, I will first keep the first function, which is e to the negative 2x times the derivative of the second, and the derivative of sine x is positive cosine x. And then we are going to add the second function, which is sine x. And we multiply by the derivative of e to the negative 2x. Well, the derivative of e to the something, first you repeat that. But the chain rule says we have to multiply by the derivative of negative 2x, which is just a negative 2. So let's put it down right here. So this is it. And then the rest is just we clean things up. For example, notice that we have e to the negative 2x in both terms. So we can factor that out all the way in the front, e to the negative 2x. And then we see this right here is from the first term, cosine x. And from the second term, we have negative 2 times that, which is negative 2 sine x. And with that, we are done. Dun, 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 dun.